In April of 1851, two lighthouse keepers stood on a metal tower in the Atlantic Ocean and listened to the structure around them begin to fail. They were not on an island. They were not on a cliff. They were not on a harbor pier with a road behind them. They were on Minot's Ledge, a jagged reef off the coast of Massachusetts, a place so low and exposed that at high tide the ocean almost erased it. Around them, the storm was rising. Waves hit the iron legs of the lighthouse. Wind tore across the lantern. The tower shook. The sea climbed higher. On shore, people could see the light flashing through the storm until it vanished. The first lighthouse on Minot's Ledge had been built with a simple idea: let the waves pass through it. Instead of a solid stone tower, engineers placed the light on iron piles, like a skeletal platform standing above the reef. The ocean could move between the legs. The structure would be lighter, cheaper, and faster to build. That was the theory. The Atlantic disagreed. By morning, the tower was gone. The keepers were gone with it. Only broken iron remained on the reef, and the coast still needed a light. This is the story of how workers built the second Minot's Lighthouse. Not on land, not in a protected harbor, but on a bare ocean rock that disappeared underwater. Before helicopters, before modern marine cranes, before diesel workboats, power tools, computer weather forecasting, hydraulic barges, and modern offshore construction systems, the workers had boats, derricks, hand drills, cut granite, iron cramps, tide windows, and nerve. They had to build a lighthouse where the sea kept taking the workplace away. To understand why anyone would try, you have to begin with the ledge itself. Minot's Ledge sits southeast of Boston Harbor, near Cohasset and Scituate, in a section of coast that had a deadly reputation long before the lighthouse stood there. The reef was not a friendly rock rising cleanly from the water. It was a broken, treacherous underwater obstruction. At low tide, parts of it could show. At high tide, the sea covered it. In bad weather, waves exploded over it. For ships approaching Boston from the south or passing along the Massachusetts coast, the ledge was a hidden blade. A vessel could be safe one moment and destroyed the next. In the age before GPS, radar, modern charts, radio navigation, and electronic depth sounders, the coast was read by eye, compass, lead line, memory, and light. A lighthouse was not decoration, it was infrastructure. It was a fixed point in darkness. It told a captain where danger was before the hull found it. Boston needed shipping, New England needed shipping. Conserve, lumber, fish, manufactured goods, people, mail, tools, rope, iron, and food moved by water. Every dangerous reef near a major approach was not just a natural hazard, it was a tax on trade. Ships wrecked. Cargo was lost. Men drowned. Insurance rose. Families waited for vessels that did not return. So Minot's Ledge needed a light, but putting one there was a different problem. On many coasts, a lighthouse begins with land. You haul stone to a site. You build a foundation. You stack masonry upward. You bring supplies by cart or wagon. Workers can sleep nearby. If a storm comes, the building site is still there when the storm leaves. Minot's Ledge offered almost none of that. The construction site was a reef exposed only at low tide. There was no flat yard, no dock, no road, no shelter, no permanent dry ground. The ocean decided the work schedule. The tide decided the work platform. The weather decided whether boats could approach at all. That was the physical bottleneck. America knew how to build lighthouses. It knew how to cut stone. It knew how to make iron. It had masons, sailors, riggers, quarrymen, engineers, and laborers. But how do you build on a rock that vanishes twice a day? The first answer was iron. In the late 1840s, the United States built an open-pile lighthouse on the ledge. It stood on iron legs, driven into holes drilled in the rock. The idea made sense on paper. A solid tower would take terrible force from waves, an open tower would let water pass through. It would use less material. It could be built faster. It seemed like a clever way to solve a hostile site. And at first, it stood. But local mariners and keepers worried about the way it moved. The tower swayed in storms, the sea hammered it. The vibration was not imaginary. A lighthouse keeper living in that structure was not standing on certainty. He was standing on a question. The storm of April 1851 answered it. On April 16th and 17th, a powerful nor'easter struck the Massachusetts coast. The tower at Minot's Ledge was hit again and again. The keepers, Joseph Antoine and Joseph Wilson, were trapped inside. They tried to survive a night in a structure that had never been strong enough for that place. People on shore saw the light until it disappeared. When the storm cleared, the lighthouse was gone. The two keepers were dead. The failure was public, visible, and brutal. It proved something engineers could no longer ignore. Minot's Ledge did not need a light that merely stood above the water. It needed a tower that could become part of the rock. It also arrived at a moment when the American lighthouse system itself was changing. For years, critics had complained that too many American lights were poorly designed, poorly supplied, and poorly managed. Some lights were too weak. Some lenses were outdated. Some structures were built cheaply in places where cheapness was dangerous.
The loss at Minot's Ledge became part of that larger lesson. A lighthouse was not just a building with a lamp on top. It was a public safety system. If it failed, sailors died. Cargo disappeared. Insurance losses grew. Coastal trade became more dangerous. And the government had to answer for why a warning light had become a death trap. That is why the second Minot's Ledge lighthouse could not be treated as a quick replacement. It had to be a correction, not only of one tower, of one way of thinking. The first structure had asked, how can we place a light here quickly? The second had to ask, what kind of structure can survive here for generations? That question changed everything. It changed the material. It changed the cost. It changed the pace. It changed the amount of craft demanded from the men cutting and placing stone. And it changed the moral weight of the project. No one could honestly say the ledge was untested now. The sea had tested it. The first lighthouse had failed that test. The second one had to pass. The second lighthouse would not be a light iron skeleton. It would be stone, heavy stone, interlocked stone, granite shaped so carefully that the tower could resist the sea not by avoiding force, but by absorbing and redirecting it. That was the breakthrough. Not one machine, not one invention, a different philosophy. The first lighthouse tried to let the ocean through. The second would make the ocean climb over it. This meant the job became much harder. Building a granite lighthouse on Minot's Ledge required workers to do three enormous things. First, they had to prepare the reef itself. Second, they had to cut and fit thousands of tons of stone so the tower behaved like one mass. Third, they had to move those stones onto a reef where the workday could be measured in hours, sometimes minutes. The engineer who took on the work was General Joseph G. Totten, Chief Engineer of the United States Army, with practical construction led on site by engineers and crews working under extremely difficult conditions. The design followed the logic of great wave-swept stone towers, such as the Eddystone Lighthouse in England. A tower like this could not be a loose pile of rocks. Each stone had to be shaped. Each course had to lock into the course below it. The blocks had to be connected with iron. The tower had to become, as much as possible, a single granite body. That meant the lighthouse began before it reached the ledge. It began in the quarry. Granite had to be cut, shaped, numbered, and fitted. The blocks were not rough stones thrown into place. They were custom pieces in a giant three-dimensional puzzle. Masons dressed them so they matched the curve of the tower. Holes and grooves were prepared for iron pins, cramps, and connections. Courses were fitted on shore first, checked, marked, and then taken apart for shipment. That is one of the strangest parts of the old method. Workers built pieces of the lighthouse on land so they could rebuild it at sea. Every error on shore would become worse on the reef. A block that did not fit at the quarry could be corrected. A block that did not fit on Minot's Ledge could waste an entire tide. And a wasted tide was not a small mistake. It meant the ocean came back before the work was done. The ledge itself had to be cut to receive the tower. Workers had to land on the reef at low water, drill into the rock, and prepare foundation sockets. Imagine that job. The boat approaches only if the sea is calm enough. The men carry tools onto wet stone. The reef is slippery. The water is rising or falling. Waves never fully stop. There is no workplace except the rock underfoot. No lunchroom. No dry yard. No scaffolding safe from the ocean. They drill by hand in a hard rock while watching the tide. When the water returns, the work stops whether the men are ready or not. That is the part most modernized miss. The hard thing was not only lifting heavy stone. The hard thing was building inside a clock made of water. At Minot's ledge, the tide controlled every decision. A crew might wait days for a safe landing, then get only a short working window, then lose the sight again to the sea. Storms could erase progress, damage equipment, delay shipments, and remind everyone that the first tower had already died there. The men working on the second tower were not building from a blank slate. They were building on a known grave. Every piece of broken iron from the first lighthouse said the same thing. Do not underestimate this ledge. The first construction seasons were devoted to foundation work. This was slow, wet, discouraging labor. Holes had to be drilled into the rock. Iron had to be set. The base stones had to be placed so precisely that the rest of the tower could rise from them. The lower stones were the most exposed. They took the direct force of the sea. If the base failed, the tower would not get the chance to prove itself. The lower courses were laid with extreme care. Granite blocks were dovetailed and connected so that no single piece could easily be lifted out by waves. The tower was circular, tapering as it rose, with a profile designed to deflect water upward and around it. A square wall gives the sea edges to attack. A round tower gives it less to catch. The shape itself was part of the defense. Every block had to arrive in the right order. Every course depended on the one below. The old construction method was brutally logistical. Cut the stone on land, fit it on land, number it, load it, transport it by vessel, land it near the reef, hoist it when the sea allowed, set it before the tide returned, lock it, wait, repeat, again and again, year after year. That repetition is what built the lighthouse. Not a single spectacular moment, not one heroic lift. Thousands of correct, small actions, done in the right order, against a workplace that kept disappearing. By modern standards, the available equipment was painfully limited. There were hoisting derricks and lifting gear, but nothing like a modern marine construction crane with precise hydraulic control. There were boats, but not modern stabilized work platforms. There were weather observations, but no satellite forecast. There were signals, ropes, blocks, tackles, iron fittings, hand tools, and the judgment of men who knew the sea could change faster than paperwork. That is what makes Minot's Ledge a built-before-machine story. The workers were not simply doing a modern job more slowly. They were doing a job modern equipment was invented to make survivable. They had to create stability on an unstable site. They had to create precision in a wet, moving environment. They had to create continuity across interrupted workdays. They had to leave the site every time the ocean reclaimed it, then return and continue exactly where they had stopped. Think about the mental burden of that. On land, a wall under construction waits for you. At Minot's Ledge, the wall spent half its life being attacked. A course of stone laid today would spend the night under waves. The next morning, if weather allowed, the crew came back to see what survived. That must have changed the way men looked at their own work. A mason on land trusts gravity and mortar. A mason on Minot's Ledge had to trust stone shape, iron connections, and the stubbornness of granite against open ocean. The early courses were the test. If they held, the tower could grow. If they failed, the whole project could become another warning. Slowly, the base rose. The sea still covered it. Then it rose higher. Waves still broke over it. Then higher still. The tower began to spend more time visible. That did not mean the job became easy. As the tower grew, workers gained a more defined structure, but they also had to lift stone higher. They had to build around a narrow, exposed column in the sea. Supplies still came by water. Men still depended on boats. A storm could still shut everything down. But each course that held gave the crew more proof that the new method was right. Stone was doing what iron piles had failed to do. The lighthouse was becoming one piece. That was the genius of interlocking masonry. A single granite block can be moved. A tower of interlocked granite behaves differently. The sea may hit one stone, but the force spreads through many. Iron pins and cramps help keep courses from shifting. The curve of the tower reduces the violence of direct impact. The weight of the structure becomes part of its survival. The old builders were not stronger than the sea. They were trying to make the sea waste its force. That is a different kind of engineering, not domination, redirection. The work continued for years. From the mid-1850s to 1860, crews returned to the ledge season after season. The lighthouse finally rose about 87 feet above the ledge. Its granite tower weighed thousands of tons. Each block represented quarry labor, transport labor, lifting labor, and the dangerous final act of setting stone on the reef. In November of 1860, the new Minot's ledge light was lit. The coast had its warning again, but now the warning stood in granite. The light eventually gained a famous flash pattern, 143. To local people, that rhythm became known as "I love you." One flash, for flashes, three flashes, I love you. That nickname can make the lighthouse sound gentle. It is not gentle. It is a monument built because the sea was dangerous enough to demand one. The romance came later. The labor came first. The tower was not built by affection. It was built by stonecutters, quarrymen, sailors, riggers, engineers, masons, and laborers fighting for working time on a rock the Atlantic kept taking back. That distinction matters. When a lighthouse becomes famous, people remember the light. They remember the silhouette. They remember the storm photographs. They remember the nickname. They remember the view from shore. But a lighthouse is not first a symbol. It is a machine for preventing death. Its job is to stand where ships should not go. And at Minot's ledge, standing was the hardest part. The human cost began with the first lighthouse. Joseph Antoine and Joseph Wilson did not die because there was no light. They died because the first attempt to build one was not strong enough for the ledge. Their deaths shaped the second tower. Every decision to make it heavier, stronger, lower in center of gravity, interlocked, and stone was made under the shadow of that failure. It is easy to say engineers learn from mistakes. The harder truth is that workers and keepers often died before those lessons became permanent. The second tower carries that history. Not visibly, not in a name carved across the lantern, but in the very fact that it is stone. The first tower trusted openness. The second trusted mass. The first tried to survive by letting waves pass. The second survived by becoming part of the ledge. And that shift came at a price. For the crews who built it, the danger did not end when the old iron tower disappeared. Landing on the reef was dangerous. Hoisting stone was dangerous. Working on wet granite was dangerous. Handling heavy blocks from boats was dangerous. Storms were dangerous. Cold water was dangerous. The schedule itself was dangerous because it pushed men to use every possible moment before the tide returned. Old marine construction often had that character. The environment did not pause for the work. The work had to fit inside the environment. That meant men rushed when conditions allowed and waited when conditions did not. Waiting could be almost as expensive as working. Boats, crews, tools, stone, and contracts all cost money while the sea decided whether the project could proceed. Every calm day mattered. Every wasted tide hurt. Every storm threatened not just lives, but months of preparation. The public saw a lighthouse slowly rising. The workers lived the interruptions. That is the part most histories smooth out. They say construction took from one year to another. They do not always make you feel the stop and start of it. They do not show men waiting on shore for a sea calm enough to land. They do not show stone blocks already cut and numbered, useless until the ocean permits the next lift. They do not show a crew working with one eye on the tool and one eye on the water. They do not show the knowledge that a storm can undo what a week of labor accomplished. That is why Minot's ledge is such a clean example of old infrastructure. The physical enemy is obvious. The ocean. The old method is visible. Cut granite, handwork, boats, derricks, tide windows. The human cost is documented. 2 keepers died when the first tower failed. The legacy is still there. A light on the ledge warning ships away from a place that once wrecked them. But the deeper story is about how 19th century builders learned to work where they could not stay. A normal construction site belongs to the builder. Minot's ledge belonged to the sea. The builders only borrowed it. At low tide, in calm weather, for a few hours. Then they gave it back and hoped the work held. That is an extraordinary way to build anything. The fact that the tower still stands is not an accident of nostalgia. It is the result of design and labor meeting an unforgiving site. The granite courses were shaped to lock together because loose mass was not enough. The tower tapered because shape mattered. The base was bonded to the reef because foundation mattered. The stones were numbered because sequence mattered. The work happened slowly because the tide mattered. The whole structure is a record of constraints. Every old machine and old method has constraints like that. Before modern construction equipment, workers could not simply overpower the site. They had to negotiate with it. On the Brooklyn Bridge, compressed air held the river back. In Chicago, screw jacks lifted buildings inch by inch. In logging country, splash dams borrowed spring water to move timber. At Minot's ledge, stone and timing answered the ocean. Different tools, same pattern. A physical problem too large for ordinary labor. A strange method that made the work possible. Men taking the risk. A structure that later generations treat as if it was always there. What replaced that old world? Modern marine construction can bring barges, cranes, pile-driving equipment, divers with decompression protocols, underwater cutting tools, concrete systems, steel platforms, GPS positioning, radio communication, protective gear, weather models, and emergency response. None of that makes the ocean harmless. Offshore construction is still dangerous, but the control is different. Modern crews can lift heavier loads more precisely. They can work from stable platforms. They can forecast weather better. They can communicate instantly. They can plan around risk with equipment 19th century workers did not have. The builders of Minot's ledge had to solve the problem with the tools of their time. That is what makes the Lighthouse more impressive, not less. It was not built because the job was easy. It was built because the danger was too important to leave unmarked. The Reef demanded a warning. The first warning failed. The second had to endure. The tower that rose from that lesson became one of the great American lighthouse achievements of the 19th century. But it should not be remembered only as an engineering achievement. It should be remembered as a labor achievement. Someone quarried the granite. Someone shaped it. Someone drilled the holes. Someone loaded it onto vessels. Someone handled the lines. Someone landed on the reef. Someone set the derrick. Someone guided the block into place. Someone checked the fit before the tide came back. Someone returned after storms to see what survived. Someone worked on a structure surrounded by the same water that had already killed 2 keepers. Those people are easy to erase because the finished lighthouse looks so clean. Granite hides effort. A finished tower makes precision look natural. The light flashes and the story becomes simple. But nothing about Minot's ledge was simple. The site was almost hostile to the idea of a permanent building. The first tower proved that cleverness without enough strength could fail. The second tower proved that patience, mass, and exact craft could make a reef carry a light. That is the central image of the story. A rock that vanishes under the tide. A crew landing when the water allows. A granite block swinging over the sea. Men guiding it by hand. The tide turning. The ocean coming back. The crew leaving. The stone staying. That is how the tower was built. Not all at once. Not cleanly. Not with modern machinery. Stone by stone. Tide by tide. Season by season, the ocean did not stop being dangerous. The lighthouse simply made the danger visible. That is what good infrastructure often does. It does not remove the mountain, the river, the reef, the mud, or the storm. It gives people a way to survive them. A bridge gives passage over water. A sewer gives way somewhere to go. A dam stores flow. A lighthouse gives warning. At Minot's ledge, the warning had to be built in the very place that needed warning against. That paradox is what makes the story powerful. To save ships from the reef, men had to go to the reef. To make the coast safer, they had to work in one of its most dangerous spots. To build the light, they had to trust a ledge that disappeared under their feet. There is no version of that story without risk. Today, when people look at Minot's ledge light from shore or from a boat, they see a beautiful old tower. They may know the flash. 143. I love you. They may know the nickname. They may know it as one of New England's great lighthouses. But beneath the romance is a harder fact. The lighthouse is there because the first one died. It is granite because iron was not enough. It is heavy because waves are heavier. It is interlocked because the sea looks for weakness. It stands because workers kept returning to a rock the ocean refused to surrender. That is what America built before modern machines. Not only railroads and bridges, not only canals and tunnels. Sometimes it built a warning light on a reef where the worksite vanished twice a day. The next time you see an old lighthouse, do not only think of the beam. Think of the foundation. Think of the quarry. Think of the boats. Think of the tide tables. Think of the men landing on wet stone with tools in their hands. Think of the first tower shaking in the storm. Think of Antoine and Wilson, trapped in a light that could not survive the night. Think of the second crew, returning to the same ledge to build something that would. That is the part worth remembering. The light is the symbol. The labor is the story. If this made you see old lighthouses differently, subscribe to Built Before Machines. This channel exists to remember the workers, tools, strange machines, and dangerous methods that built America before modern construction equipment took over. The algorithm remembers the pretty beam on the water. It remembers the postcard. It remembers the romance. But it forgets the men who had to build the tower where the ocean kept taking the ground away. Minot's ledge was not conquered. It was answered with granite, with patience, with labor, and with a light built on a rock that the sea never stopped trying to erase.